Hello and welcome to another video from oorail. So this is our very first Tech Tuesday. It's January 2016 and this is a new segment that we plan on releasing every Tuesday throughout the year. So hopefully by the end of the year we'll have a good collection of videos related to kind of electronics and programming for model railways. So I'm going to try to keep this as simple as possible. I understand that a lot of people come from various different backgrounds and not everybody has a technical background. So there's no such thing as a dumb question. So if you have any kind of question at all, or I say something in the video that I didn't explain or you'd like explained maybe in more detail, please put it in the comments and I'll try to oblige you as quickly as possible. Now I am filming these a couple of weeks in advance, so if you ask for something today, it may take 2 or 3 weeks for it to show up on the Tech Tuesday video, but I will try to answer it in the comments. Alright, so today we're just going to go through some of the basic stuff that you need. I know I have quite a lot of stuff here laid out, and I'm just going to go through the basics, and it's stuff you can acquire over the next couple of months as you kind of try out some of these projects. So the very first thing that you're probably going to need is a decent soldering iron. A lot of you probably already have one. This one is one I picked up for $10 on Adafruit. It's a 30 watt and it's by a KNS engineering company, and it's just a very basic soldering iron with a standard tip on the end. You may want to invest in some additional tips. You can remove the Phillips screwdriver here and remove the remove the Phillips screw and remove the tip and replace it. So it does take quite a while for these tips to wear out. One thing you do want to do is you want to leave some solder on the end of the tip so that you don't kind of overheat it or damage it. You certainly don't want to get like plastic insulation or other things on the tip or you'll ruin it. So in addition to the soldering iron, you'll also need what's called a desoldering tool, or a solder sucker as it's kind of more affectionately known as. And these are pretty cheap. I think I got this one for a couple of dollars on Adafruit. You can get them off eBay from China for dirt cheap. You can get them from Farnell in the UK as well. And it's a very simple tool. You basically, if you need to remove some solder, you heat the solder up and you get this, basically push this down like so. You get it close to the tip without touching it, basically placing it on the just slightly above the solder or in contact with the solder, and you basically touch it for a split second and push the button, and what it does is it basically pulls the liquid solder into the canister here. You can wait a few seconds and then just simply push it back out, and you can see there it's got a bit of a metal tip on it that will push the now solidified solder out, and you've got a nice clean connection. This isn't something that you ultimately need a lot of the times, but if you have to remove solder from locomotives or other projects, it's well worth picking it up, and it's only a couple of dollars, and it's well worth the hassle of not having one. Now the other thing you're going to need is a soldering iron stand. Now a soldering iron stand is pretty cheap. You can get them for maybe $5 to $20 depending on how sophisticated you want one, and there's not much to them. We'll show you here. This one hasn't been opened. You basically get a metal stand, and I'll show you how to assemble it real quick. Sometimes they come with a bolt and sometimes they just already clip together. So this one's got the metal base, which goes this way, and you have what's called a kind of foam pad. Now this is something that you get wet, and basically when you need to clean the soldering iron tip, you basically slightly depress it onto the foam pad. So this thing's really cheap. This one I think I got Adafruit for $5 or $6. You know it's cheap because the foam pad is really thin, and you probably want to buy a few additional ones of those if you can find them. The stand is reasonably easy to assemble. Now I don't think it came with any instructions. Yeah, of course it didn't. So hopefully this is straightforward. I've never actually seen this one before. Okay, so it looks reasonably straightforward. Oops. Lose the pad. So this, more than likely, I have no clue how this goes together. Basically needs to sit like this, so I'm guessing. Oh, I see. So yeah, so it clipped this part here, basically clips in there, and then you have this hook eye. Oops, drop it. You have this hook right here. That's we're gonna run the bolt through. So we're gonna take. This might be a little tricky to do on the camera, but I'll try to do it. You're gonna undo the bolt on this side. It does come with an extra washer. So we're going to run that through there, and you do see the washer does fit it. So put that in there, clip that in like so. I'm actually going to put the other washer on the other side like that, and then take the I'm probably going to need a screwdriver to do this, maybe not. And you just get it and twist. Looks like I will need a screwdriver to tighten it. At least a good pair of pliers, but you get the general idea. This is basically for holding the soldering iron. So the soldering iron did come with this little stand, which kind of clips onto the underneath, but you no longer need that if you can basically fall over, so it's not really that safe. This is much better. You can see there it fits into the stand very nicely. So in addition to the solder sucker, soldering iron, and the soldering stand, you're also going to need some solder. This stuff is resin core solder. I got it at Radio Shack a few years ago. It's a decent sized spool of it. If you buy a big spool of it, you're probably only going to need to buy it once or twice in your lifetime, unless you do a lot of projects. So it's always handy just to buy a big roll of it. You can also use this for wiring, so because it's so flexible. If you need to kind of duplicate hosing or wiring or something on your layout, you can use this, flex it into whatever position you want, and paint it. So it's always good to have some solder laying around. And then finally, the last tool that I use is a set of electronics tweezers. These are handy, especially if you need to, you've got big hands or you've bad eyesight. These things are very handy. They come with a little safety clip thing that you can keep them clean, and you can see there they're very, very fine. So you can use these to pick up electronics or mount them into boards or into breadboards, especially if you're dealing with electrostatic sensitive equipment. So these are very useful to have, and they're just a couple of dollars, so it's well worth it. Now, I will say that if you a lot of our viewers are a bit older than I am, and even my eyesight's not that great sometimes, so a pair of helping hands is also a good tool. Now these you can get these anywhere. I think they have them pretty much in any kind of store. You can also get them in electronics websites like Farnell. But basically it gives you a magnifying glass and kind of 2 sets of crocodile clips that you can hold things, and this makes it a lot easier to see what you're doing. Obviously, you don't want to use the metal clips on anything that you can damage, like tracks on a PCB. But for soldering wires together or wires on components, it's very handy. Okay, so the next thing that you're going to need are breadboards. Now breadboards are basically a very easy way for building circuits using various different electronics. Now the nice thing with these is they have rows that go this way and columns that go up and down, and basically the columns that go up and down are connected together. So these here are connected, those are connected. Let me see if you can see. These are connected. These are connected, but these two here are not connected together. So if you want to connect, say, a piece of electronics that's here to a piece of electronics that's here, you can just use a jumper wire to do that and build your circuits. So you can put like chips or integrated circuits across the center here, and then wire up the individual pins to different electronics and build out your circuit. So rather than having to solder things and get things together like that, you can build them out on little breadboards like this. So breadboards come in a wide variety of sizes. This is a tiny breadboard that Adafruit sells. It's pretty small. They have slightly bigger ones, like you can see here, that have connected to the Arduino. You can get very, very big ones that are pretty long. Now they range in price, and these can be expensive. They range in price from $1 or $2 up to $4 or $5. I have found on eBay though that you can get these from China, especially the longer ones and larger ones, very, very cheaply. I think they're less than $1 a piece. So I've actually placed an order with a couple of different Chinese suppliers in Hong Kong via eBay, and hopefully we'll get some of those breadboards in the next couple of weeks. Now it does take a while to get some stuff from China, but it is dirt cheap compared to what you pay from a regular US supplier, so it's well worth your while. Maybe stocking up on a couple of breadboards. You will use them, and if you want to have a couple of different projects on the go, it's very handy to have a few of them laying around. So you can see here I've got the Arduino connected to one of these breadboards and a bunch of resistors and other things. So this is actually just a basic analog circuit that's designed to run some LEDs and do some simple code. And I'll show you how to do this in an upcoming video. But basically I just wanted to show you that this is basically how you test out a circuit. And what you might do is, if you only have one Arduino but you have multiple maybe breadboards or projects going on, you can use a small breadboard like this, maybe line up the pins like this, and then just move the wires from the Arduino to the small breadboard, and then set that aside, and you can take the Arduino board, put different code on it, and plug it into a different project, and then work on that project for a bit. So you don't necessarily need to have an Arduino for every project that you're working on. You can use the breadboards to sort of split your time and test stuff out. What you don't want to do is have just one breadboard and be working on multiple projects and have to tear everything out and start again. Now when you're happy with the project, you can transfer the electronics and the circuitry to a PCB, and I don't actually have any more of the sort of solder PCBs with the holes in them. I do have more on order, so when those come in I'll show you those. But it's basically a very similar process, but instead of having the circuits like this with the holes in it, it's basically a very wafer thin copper board, and what you have to do is basically cut and solder the pins of the electronics onto the underside of the board. In addition to the PCB or the breadboard, you're going to want some wire bundles. These are reasonably cheap. You can get about 30 or 40 of them, multiple different colors from Adafruit. You can also get them from China. I found on eBay a couple of suppliers selling 650 of them for like $8, so you could always buy 1 or 2 batches from them and then never have to worry about needing wires again. So yeah, so that's basically the basic stuff that you'll need. I would recommend picking up some terminal blocks as well, especially if you're interfacing circuits with your layout. You might want to even have, like I have here, a test track, and then you can sort of wire or have a block of these sitting between your test track and your circuits, so you can try out different projects, especially if they have to communicate with the track. Other things, it's always handy to have some LEDs. Now, I bought all my LEDs from a place called led-switch.com here in the United States. You can get LEDs pretty much anywhere, so Farnell in the UK is a good option. I think they may be part of the newer Element 14. So definitely LEDs. Now I use 2mm and 3mm LEDs. You can get 5mm LEDs if you want. I found that the 2mm LEDs, or the pinhole LEDs, work very well for various projects, from locos to signals to just internal lighting in buildings. So it's always worth your while picking up some green, red, maybe some amber, and possibly some white ones as well. In addition to that, the Arduino uses a shield system. Now what a shield basically is, this is an Ethernet shield. It's basically a kind of additional circuitry that can be dumped on top of the Arduino to provide a function. If I pull this out very carefully, I'll be able to show you without bending the pins here. This is a Ethernet shield, so it has an RJ45 jack that would plug into your Ethernet, and this basically gives the Arduino a ability to talk to Ethernet devices. So there's a Ethernet library that you load up, and then you can use that to have your device talk to the internet. Now this, you can see here, has a bunch of pins on it, and this basically sits down into the Arduino. So it would go, I don't know, break it, but basically it would go down on top of these here and here, and then obviously it exposes those through it, so you don't lose your digital input and outputs for your project. So these are very handy. They're also pretty expensive. I think this was like about $30 to $50 depending on what kind of shield you want. However, it can provide you with really quick ways to prototype or add functionality. They do have Wi-Fi ones. I have an RFID scanner one as well. So they are pretty cool. But what you can do as well is, if you want to build your own shield, they do sell a kind of breadboard-like shield called a prototype shield that you can purchase from Adafruit or from various other Arduino folks. But you may want to pick up some of these kind of stacking headers. They come in different sizes, and basically allows you to stack things on top of the Arduino if it's not in a kind of a shield format. It's probably useful to pick up some resistors. You can see here I've got a collection of various different resistors. I normally work with 3 volt, 6 volt, 9 volt, and 12 volt supplies. So I basically purchased resistors that would allow me to drop 12 volt down to either 9 volt, 6 volt, 3 volt, or 3.3 or 5 volt. In the upcoming video, I'll show you exactly what kind of resistors you need for different voltages. The reason I say that is that most of the power supplies, so if you want to reuse an old train controller or something like that, those power supplies are going to be 12 volt power supplies, or DC. So using the resistors to step a 12 volt power supply down allows you to use the old train controllers very quickly and very easily as external power sources. You don't have to worry about trying to build or purchase an external power supply. Other kind of cool things that are kind of not really things you need, but are worth picking up just to play with electronics. The 7-segment display is basically very useful for kind of display panels and stuff like that. The nice thing with the Arduino is it does come with a sort of a back plate or backpack, as they call it, that allows you to integrate the 7-segment display. Basically sits on top of it. It allows you to integrate that into your circuit, so you can basically plug the 7-segment display into that, solder it, plug it into the Arduino on the breadboard, and start using it. So it's very kind of nice. You can also get some servo motors. Now the servo motors can be possibly used to drive things like point motors, or other things you want to move on your layout, or they can be used instead of point motors as well. So these things require a kind of a shield similar to this, but for driving servos and motors. So we'll show you what kind of shield and how to utilize it in an upcoming video as well, because servo motors are pretty handy. Other than that, that's basically the basic kind of stuff that you'll need. So hopefully I haven't confused too many people. I do have some other stuff sitting here. Now this is stuff that you probably will end up having to buy at some point if you're producing kind of more complicated circuits. We have some diodes and some transistors. Also these nice little storage boxes cost $1 or $2. This is a large modular snap box, and they basically kind of hook together, so you can stack them up, and it's a good way, especially if you're like me and don't have a lot of space here. You can use these to store your electronic components. The other thing that you need to be careful of is that all this stuff is electrostatic sensitive, so if you walk across your carpet and start touching the stuff, you could possibly damage it. The best way to get rid of static charge is to basically roll up your sleeves and touch something metal, something substantially metal as well that's grounded. So you know, like a metal pole, your computer, if it's not plastic, you know, the tripod here on my camera system, the case here on the Hamilton Morgan power supply. So basically just something that's grounded, that's just gonna, you know, drain that side electricity from you before you start messing with this stuff. So yeah, so I've used computers and built computers since I was about 8 or 9 years old, so nearly going on 30 years at this point. So I've never blown up something ever with electrostatic discharge. So as long as you touch something metal, you should be perfectly fine. Alright, so that wraps up this video. So hopefully you guys have a basic idea of what's going on. Oh, I do have one more thing to show you. So in addition to the Arduino, which is a kind of microcontroller, we will be showing you some other products as well. This is from a company in China called Redaxa. I believe it's their Redaxa Rock product. And this is actually an Android / Linux embedded computer. You can see here it's got a HDMI, Ethernet, 5-volt DC power supply, some USB ports, and so on. So this is actually a fully fledged computer. I can't remember how much it costs, maybe $80 or $90. You basically plug a USB keyboard into it, plug your TV or your monitor into it via the HDMI, and power it up, and it gives you basically a basic computer that you can use. As you can see here, it does have Ethernet, and I believe it has embedded Wi-Fi as well, which is what this kind of wireless connector is that's sitting there. But one of the reasons I have the shield here with Ethernet on it is to be able to connect the Arduino to this type of a board, and because it's running Linux and Android, you can boot either one of them. It does allow you to then maybe possibly control or pass data to the Arduino products on your layout. This is another product, and it's very similar to Redaxa. This one is from a company called Cubby Truck, I think, or it's called a Cubby Truck. This particular board is a Cubby Truck. I think it's from Cubby Board, maybe. I'll put the link on the description, but basically it's the same idea. It's got a VGA connector instead of HDMI. It's got Ethernet. I'm not sure if this one has wireless or not. It may not. It has USB connectors and a few other audio connectors. So this is basically a very, very small computer. You plug your keyboard into the USB. It does have HDMI actually, and you can use VGA or HDMI, and it's got the Ethernet on it as well. So you can use this to possibly control some Arduinos and build out your kind of control center that way. It's totally up to you, but we'll be using these on a couple of different projects. We'll also be using the Raspberry Pi. Now I believe both Arduino and the Raspberry Pi have a similar product to this, either out or coming out. So we'll take a look at those maybe throughout the year as well. So we'll be, like I said, doing a lot of the prototyping on the Arduino, and then we'll be moving the code out to either the kind of Arduino Nano, or moving it out to the Arduino Mega for some of the bigger projects. Now the key difference between things like the Arduino Mega and the Arduino Uno is that the number of digital input-output pins that these boards have. And so basically the digital input-output pins will allow you to control external devices, so number of LEDs you can hook up, the number of input sensors you can read, and so on. So you do a lot of very cool stuff with this stuff. This is just kind of a building block. You can put sensors, so where I have LEDs, you could put pressure sensors, you could put photo detection diodes, you can put almost anything you want. So the sky's the limit with these things, and like I said, we'll be building up code and various different things related to motor railways using this platform over the coming year or two. Now, I do realize that some folks pulling down code from GitHub might be a little tricky for them, so we will try to simplify that process as well. I might do a video on using GitHub in the near future. Alright, so that's it for this video. Hopefully you have a kind of basic idea of some of the stuff, and maybe a little bit less scary, or maybe more scary. Hopefully it's not. If you have any questions, put them in the comments below. And next week we'll be taking a closer look at the Arduino and how to get started with it, hooking it up to the computer, installing software, and so on. Alright, so hope you enjoyed the video. Please let me know what you guys think. Leave some feedback, and until next time.